about harmonics. And, this isn't something that's just, specifically related to the Pittsburgh Modular Taiga, but it is something that you might think about when you have three oscillators, because having three oscillators isn't just you having the opportunity to go like, okay, there's one, there's two, there's four, there's three. Listen to how big that is. Okay, yeah, that's super cool. But we're missing a real opportunity here because the original reason that multiple oscillators were put on synthesizers wasn't to layer a bunch of oscillators on top of each other, although that's part of it. Because when you do layer them on top of each other and you choose different waveforms for each of them, you're making a complex waveform, and that is a desired outcome. However, there was also the possibility of doing this the old style, which is additive, which is what I want to show you today. How you can make timbres using oscillators set to different frequencies and amplitudes. So basically we're starting with, let's put everything on sine wave. Which you might think, gosh, yeah, sine wave's the most boring wave. And that's the magic of additive synthesis. Okay, so we have the sine wave that this can make. I wonder if this is entirely a perfect sine wave. We don't really know, and it doesn't really matter. Additive actually can work with any waveform, not just sine waves, but sine waves affords you the most accurate control in regard to additive synthesis. So what we want to do then, we could layer, but when you layer a sine wave, it's just like you're barely doing anything. It still sounds like a sine wave. It has some sort of weird different character, but it still sounds like a sine wave. The trick is to change the pitch of the second note that you've layered on top. Now you have what I often call the prog rock lead solo sound. But the whole trick about additive synthesis is causing the oscillators to act like harmonics. And the crazy thing about harmonics is, in the harmonic series, the second harmonic, you've got the first harmonic, the fundamental, which is the frequency of the note. Basically, in this case, we're talking like, there it is. There's your fundamental. It's just a sine wave A. Your second note is going to be something different. And more importantly, it's going to be half of the amplitude of the first note. So even if you take two sine waves and you change the pitch of one of them and then bring it to half of the amplitude, you're going to notice a new timbre. And if we drop it down, so even more, because I'm not sure that this is 100% accurate, where all the way up is 100 and all the way to the left is 0. So you can hear the point at which the fifth that I've programmed comes in. But if you drop it down enough, it stops sounding like another note and starts sounding like a different timbre. You're not hearing that and going, oh, that's two notes playing. You're hearing that and saying, oh, that sounds like a different timbre. And then we can bring in the third oscillator. And then we will drop that down so we can barely hear that one. Right now, we can easily hear all of those other notes, but we want to have them at least audible enough because act like a sawtooth in itself has an infinite amount of harmonics. If you take these harmonics, we're only working with 3. If we take them and we we drop them down in amplitude to the point where they're not really heard, we're not going to hear a huge timbral difference. Anyway, that is you can hear it as a chord down below, but as you're playing it as a melody, it doesn't sound like you're playing chords. And that is how additive synthesis works. And of course, if we had a synthesizer that could only play sine waves, but you could control the amplitude and pitch of them, you'd be able to create different timbres. You might remember the Korg Delta. The Korg Delta had 4 square waves. And that's all it had. And so basically any of the timbres, wait, was that the Korg Delta or was it I think the same thing happened with the Roland SH3A. Basically you just had a set of square waves, 4 different square wave oscillators, and it was mixing them together that gave you the timbre, which is so weird. But that's how it worked. It was just additive and combining waveforms at different amplitudes and frequencies provided you with your outcome. So I just wanted to be clear that this is a thing that you can do. Obviously, with the Taiga alone, you could do this. And if you wanted to be really obnoxious, you could, in fact, let's see, you could do this with your filter. I have just basically turned up the resonance to the point where it's kind of self-oscillating, and that adds another sine wave to our mix, giving us a new timbre. Anyway, this is just a really simple way of showing how additive synthesis can be applied in a 3 oscillator synthesizer in order to create new timbres. And I just want to kind of drop that in there to show you that the Taiga can, help you engage in traditional synthesis forms. All right, this is the Pittsburgh Modular Taiga.